Hi, this is Margo. This is Sunday morning, October the 20th, 2019. I hope everyone is doing well. I apologize for not doing more updates, but I'm still very busy with taking care of my friend's stuff. My friend who died a month ago, well, a little over 5 weeks ago now. And I've got stuff to go through, storage units and different things, and it's taking me time, it's taking a toll on my physical body and my health, and so, but that's kind of top priority right now to get all this stuff, under my belt and behind me, and so that I can move on. And it's not easy. It's certainly not easy, especially when you reach 65 and a half years old and you have health issues, and you have to go through it. You have to go through the stuff because there's good stuff mixed in with the trash. So that's the way it is, and when you become a caretaker, your life is not your own anymore, for a while at least. So people who have done that will know exactly what I'm talking about. But today I'm going to bring you a sea ice update, methane update, and a little bit of a climate roundup. We're also going to look at some of the sea ice in the Antarctic, but I want to start with the Arctic sea ice. I have a slideshow ready for you. This is where the sea ice is at today on Sunday, October 20th, sea ice and snow cover. This is from Climate Reanalyzer, and so this is how it's come back out. My last update was on September the 30th. So I've been saving the pictures every day. I missed one day. But so we're just going to click back through and have our own slideshow and see what's happened with the sea ice since our last report on the sea ice on September the 30th. And when it's been a few weeks, like it has here, we can see a noticeable change, and we can see, okay, so here's where it was on the last report, where it was starting to come back out on the extent on this top edge, and down here, coming down here by Greenland and filling in these island areas, in the Canadian island areas, and struggling to come back out in the Beaufort Sea, but that's kind of holding right there. But when we click back through, we can see that it's starting to, the extent at least, is starting to come back a little bit. We can see it growing. We can also see it getting a tiny bit thicker, but not that much thicker. When it goes from blue to more white, it means it's more concentrated. And so here it is on today, where we can see it's meeting up with some of these little islands next to Siberia. And this is the East Siberian Ice Shelf right over here. But there is methane coming up, and I will show you all of that. It's also dark up here. I'll show you that on NASA World View, because the sun is going down in the Arctic as the Earth tilts the northern hemisphere, and the North Pole tilts away from the sun, and the sun is up in the Antarctic as the southern hemisphere and the South Pole tilts towards the sun. Next, here is the Navy GIF from yesterday. It was from the 19th, 10/19. This is showing the thickness, and so even though the extent is starting to come back, it's quite thin. It's in this purpley, between 0 and half a meter thick to when it gets into the dark purple and into the blue, it's 1 to just a little bit above 1 meter thick. And so this blue is about 1.25 meters thick. So it's not very thin. It's not very thick, and so it's not well formed or thick at all. Here we can still see, if we blow this up, it's quite thin. There was a hole that developed here to the right of the 90-degree north latitude, which is the North Pole. It's still quite thin there, and the aqua is the thicker areas, and there's a little bit of red and yellow and green, which is thicker just right to the north of Greenland. So that's where we're at with that. Here's the 30-day animation from the Navy GIF. It goes back 3 weeks and forward 1 week. And so you can see the extent kind of coming back out up here, moving into the Chukchi Sea a little bit, and trying to come back in the Beaufort Sea, and just trying to fill in a little bit, but it's still quite thin up here. But this is the beginning of the refreeze, if you want to call it that. I made this movie this morning. This is from NASA Worldview. This is the sea ice concentration from September the 28th to October the 18th. And where you see it blue, that's where it's not as thick or concentrated. So now it's starting over on the animation here. And it's 1 day. Each image is a day. I'll let it run through one more time. So this correlates with the fact that even though some extent is coming back, it's still quite thin. So I'm gonna move that back to there, so that's not going the whole time. Next, I want to show, I'm gonna stick with the Arctic while we're here. I have the National Snow and Ice Data Center website pulled up. Here's the sea ice concentration from yesterday. We see that it correlates to what we saw from the NASA Worldview. Now, here's their graph for the extent, and we can see this dotted line was 2012, where it was at the lowest ever in recorded history on record. And so we were below that line in July, in the first part of August, and then 2012 went lower than that, And now we can see we're below 2012 at this mid-October. So we're at the lowest Arctic sea ice extent on record right now for this time of year. So that's not looking good. Also, here's NASA Worldview. Let's go back to the Arctic. Not all the data is in yet for today, so we still have some missing over here on the left-hand side of the screen. But if we go back to yesterday, let me refresh. That was all in. Here we go. This circle that's what's in the dark right now as the sun is setting. So a lot of Greenland is in the dark, and the North Pole is definitely in the dark. Svalbard is in the dark. These little islands are in the dark. It's coming on over to Siberia. Here's Novaya Zemlya. I'm going to zoom in a little bit. We can see this northern tip of Novaya Zemlya is in the dark. And the mainland of Russia right here, this little tippy point, is in the dark. And so the only way to see the sea ice, there is a layer, there is a nighttime layer that you can overlay. It's kind of weird looking, and it's a lot of lines on it. I don't like it. It's hard to read, but Sam Carana seems to like it. I can show you that layer. Add layers. Earth at night. Nighttime imagery. And that's what it looks like, that layer. And so you can't really tell anything from out here. If you zoom in, you have to figure out what's clouds and what's not clouds. And it's just, then you got all these stripes as part of the thing, and it's just hard to tell anything with this layer. So I don't see how you can really see much with this layer. Because you've got clouds, you've got ice, you've got these stripes as part of the model, I think. And you've got the sun going down a different, and it's different angles and things. So we can see that there's no sea ice over here on the west of Greenland. We can see that. But Sam Carana was showing the sea ice north of Greenland. Now here it is. It's so dark. I mean, you'd have to... Now that's a pretty good image from the 16th. You'd have to take a picture and do some lightning to really tell a whole lot. But we can see that there's still a lot of open area around the coastline of Greenland. And a lot of big chunks. But as the ocean currents move, it pushes the ice back up to the edge. But that hasn't started happening yet, and I think that was his point. But that's that layer. I don't use it very much, simply because you've got all these lines and other stuff to look at. And and you've got the clouds to deal with, and so it's hard to determine what's really going on with that much accuracy. So I look at this layer when I make those GIFs, see, and then I turn on the blue marble layer. So all you see is the sea ice concentration. And so here's that layer, sea ice concentration, and then if you run your pointer over it, it'll show the level of concentration over here on the graph. Like down here, that's about 40% concentration, and so on. And you can see where it's starting to refreeze around the coastlines a little bit, and in these little tributaries. So that's how I look at the sea ice in the wintertime up there. So there's that. Now, while we're on sea ice, I want to go to the Antarctic. There was, let's come on over to today. Okay, all the data's in today for the Antarctic. Here's what it looks like. Here's that A68 iceberg that broke off a couple of years ago from the Antarctic Sea Ice Shelf. It's rotated around, and this little bit of sea ice is all that's holding that in. But I think it's got quite a bit of movement going. It's got a lot of momentum. Here's where it broke off. This line here is where the ice shelf used to come out to, but this shows where it broke off, and this is the piece that broke off, chunk, and it's been rotating. We've been watching it. It broke off in, I think it was July of 2017. So we've been tracking that. Huge iceberg. So it's kind of started breaking apart over, you can see where it's kind of going in there, where it started breaking apart a little bit, but that's a pretty good image of it. So it's on its way out. And we can see where the sea ice has come away from the coastline and the ice edge already here. Big break. And so this is melting quickly. Over here, this is the Brunt Ice Shelf, where the research base, they had to be airlifted because there were all these cracks coming, so that might calve off soon. Down here, gotta get oriented. Up. Down here is the Pine Island Glacier. It's got an active volcano underneath warming up everything. And this calved off, huge piece calved off last year, and this is the open area where the sea ice has already pulled away, and this line is where this Pine Island Glacier, where it used to come out to, all the way down to here, but it's been calving off. So that's what that looks like today. Down, oh, here's the Thwaites, this area, the Thwaites, that had a bunch of ice loss. That's what that looks like today. Down here is the Ross Ice Shelf and the Ross Sea. We can see that that's melting around the coastline. Here is the Ross Island with, this is Mount Erebus. This is an active volcano. It's always sending up smoke, always, and you can see it right there. There's no clouds down here. The McMurdo base is somewhere around in this area. Here, these are all mountains. Antarctica doesn't get very much snow. It's pretty much a desert. It does get some snow, but the interior is like a desert. So we can see that pretty good today. Then, of great interest, at the end of September, I think it was the 25th, there was a big chunk that broke off of the Avery ice sheet. This is the Avery, or Amory, sorry, Avery Ice Shelf. Big chunk. This is where it used to come out, and now that piece has moved around. I'll show you. Here's the piece. This is a pretty good picture from the 15th. This is the piece that's broken off. If we go back to September, this is before it broke off. That's what it looked like. Here's where before it broke off, and you see the ice had already melted away. There was no ice around this edge, and it was starting to, it's like the ice is moving out. This is still before the break off. Here's the 23rd. That's a pretty good view. And we can see it cracking down here. So here it is on the 24th. So here's the piece. And here's the 25th when it cracked off. Now here's a cloud over it, but you can see that's as close as I can go in, where it cracked off around this edge here, and then it's moved out. And it's moved out really fast. And I've made a movie of this. I want to share that with you. Well, let me find it. Here it is. Let's open that. Here it goes. There, it's moving along. There it is today. And now it's starting over. You can see it. it's moving so fast. I couldn't believe it as I was watching this progress. And it hasn't even been a month yet. So that's going to go out to sea, it looks like. Looks like there is a piece of ice extended here that it's running into by the time it gets to the end. Here it is today. So it's going to be running into this piece of ice, it looks like. So I don't know if it's going to start breaking up or if it's going to start making this part break up, or it's going to go further out to the east, or what's going to happen. So we'll be watching that. So those are all of my ice images for you. Now let's head over to methane. Here's our latest methane data on CAMS. It's from Friday the 18th. I have the Arctic view pulled up, surface level, and here's where it left off on Thursday. And we're seeing these the color changes in the Arctic going from darker green to lighter green. You're going to see some yellows coming out over here too. Now the articles that have come out about the plumes from Bennett Island, saying that they've never seen it this high and all this. If you do some research, there have been plumes, mysterious plumes from Bennett Island or near there since the early 1900s that have been documented. And I think it's from earthquake activity and volcano activity underneath there. That's what I think. But maybe they just weren't able to measure it like they can now. I don't know. But it's all very active up there. So we see this arm of this methane coming down and then out and around. And remember, this is in the dark. And this is coming up through the sea ice. This is surface level. Now this area over here doesn't have sea ice yet. But so far the sea ice has come back to this area. I think this area here. But it's quite thin. So we're seeing huge releases on land in Russia and Norway, and here's Iceland. It's releasing. There's still some releasing on Svalbard. It's in the dark now. There was an article that just came out about this area down in Siberia, about right down in here, where it's so hot. The methane is coming up and permafrost is melting and is changing the whole landscape. And the towns are changing and people are losing their livelihoods, and the rivers are higher and all this stuff. And we can see certain areas. Russia has just constant huge releases of methane. So I'm not surprised about this, and this is going to happen more and more and more, and it's not helping matters any. So this lighter color green is about 1980 to 2000 parts per billion. Then the chartreusey green is 2000 to 2020, and then once you get into the yellowish, like right down here, 2020 to 2040. This orange color is 2080. The red, bright red, is 2000. And then this dark brown red is 2160 up to 10,000 parts per billion. So it's a range. So even the green, it's very high. It's very high. Let's go to the North Pole view. We can see the whole northern hemisphere here. And we can see India has a lot more releasing, and it's coming up to the west of India and to the east, China and Asia and so on, and then all the way through Europe, European nations and countries. Also over in North America there are high releases. If you run the movie, you'll see. If we run this movie, it might take a few seconds for it to load up. And we can see this wave moving out from North America out across the Atlantic Ocean here. Huge, huge wave. We have high releases down here in California, especially Southern California, where lots of earthquakes have been happening. And if I had the time and the energy, I would be doing more earthquake reports too. But I'm clearing out storage units, and because of my health, I can only do 2 or 3 hours at the storage unit like every other day. And then it takes me a day to recuperate. And on the days I'm recuperating, it's hard for me to talk because the whole thing. And I'm tired and dizzy and all this. Now look at this area here in North America. Let's just go over to North America, because this is disturbing. Let's go back to the beginning. Now see, here's Southern California. This is the area where we're seeing the earthquakes, a lot of earthquakes. Here's Florida, here's the Midwest, and here's this huge release area up in Canada. And then over here, the Rocky Mountains go up into Canada in this area. Look here up through California. This whole southern area is of great concern. Now look at that. That's in the forecast period for today, Sunday. Look, and then the wave moves covering the whole Northeast and Canada and covering up a lot of Florida. So huge methane releases now. Look how it moves down over the Pacific Ocean to the west of Baja in the forecast period. So this is pretty severe, I would say. Ozone is not looking good either. Ozone is in very bad shape. We might take a peek at that too. I also wanted to show, while we're here, I wanted to go to, well, we'll do total column in a minute. Now we'll go to global view for methane, and here's what it looks like globally. And then total column, totally awful. It's just horrendous. Look at the dark areas. Let's do a refresh and we'll get the correct color ledger for this. So for total column, this dark brown is between 1920 to 2320 parts per billion. And then this red, this darker red, is 1900 to 1920. This orangey color is 1860 to 1880. But look how it just covers up and then it goes across the Pacific Ocean. Now look at this orangey color, this 1860 is actually coming out over the Atlantic now. And now we're seeing reddish colors over here in the Pacific. I'm going to switch to the Pacific view for this. This is the first week I have seen red coming out across the Pacific and over the United States. This is the first week. It happened on Tuesday, actually, where I saw red over California here. So if we zoom in to North America now, we can see that's over Southern California. But it's a whole wave that's coming in, how it's spread out. That's the first time I've seen red though over North America. So this is very disturbing to me. While we're here, let's go back to global. Let's go to 500 HPA. This is about halfway up in the atmosphere. And this is what it looks like. And we'll refresh to get the color chart. And there's 500 HPA. And this like chartreusey color, it's into about 1860, 1880. This kind of golden color is 1900. Up here, 1900 parts per billion. So most of the northern hemisphere is above 1900 parts per billion. At this level, 500 HPA. So while we're here, let's look at the NOAA data. I've been collecting the NOAA data for 477 millibars, but that's what it says on the little GIF when you choose it, but when you go to the picture it says 469. Anyway, been collecting this data from NOAA since March the 1st, just tracking methane to see. There are two satellites, METOP1 and METOP2. They take a reading in the morning and the afternoon, so we have 4 readings a day. Here is the data from yesterday, the 19th. And the average, it went up to 2567 parts per billion. That's the highest reading. And that's in this fuchsia color. The range is from, I don't know, you have to figure it out. This orangey thing is 1500 up to 2000. Looks like 2000 up to, that's 2000 I think. So it goes up to 2567 in this fuchsia range. The mean was 1895. Last week, this reading was 1900, but there was a lot of missing data. We do have missing data here, this big white area and that big white area. In the afternoon, it was 1895. In the morning, on METOP2, it was 1875, and this satellite always reads lower. And in the afternoon, it was 1874 for the mean. But the highest reading was 2328 there, and 2329. We also are seeing some pretty good size releases from the Antarctic. Now I put those into the spreadsheet. Here are the 4 levels from this week, and added them up and divided by 4. And the average for the 477 millibar reading for this week is 1884.75 parts per billion, and that's down 1 parts per billion since last week. But since March 1st, it's still up 27.5 parts per billion. So here's the chart. Since March 1st over to here, and we can see that it'll go up and down, but it's generally, it's a steady increase since March the 1st. So here we are right here. So there's that. So let's briefly, this is kind of getting long. Oh, I was going to go over ozone. That's kind of flipping me out. We'll end on ozone, or we might just take a peek at Climate Reanalyzer. Ozone is current. Let's look at it from today. Here's total column from today. This is measured in Dobson units. Yellow is 300 to 320 Dobson units. 300 is considered to be average. And so anything to the left of the yellow is below average, which means the chartreuse and the blues and the blacks, those are all below average. And anything to the right is above average. And so what we see is this thinning of the ozone layer throughout the mid-latitudes, going up into the Arctic. So from from about the middle part of South America and the southern part of Africa and the northern part of Australia all the way up to the Arctic is quite thin. We have this chartreuse color is 260 Dobson units. So that's this color we can see all the way up. Then we have the 280 right here, 280 Dobson units, and then a little bit of yellow mixed in, and then a little bit above that here and there. And then we have this aqua color, this 220 to 240 also. And then below that we have 200 down here in the Antarctic, and below that is 175 right here. And this black line separates the 200 to 220. That's kind of a critical area in the ozone. And this is the hole over the Antarctic. So we're seeing holes appearing all the way through the ozone layer, all the way across the planet. I haven't seen it like this before. I sent a picture to Robin a few days ago and showed him how these holes were developing and how shocked I was, because it had been a while since I had really looked at ozone and I hadn't seen holes like this ever. I've seen like a thinning or like a hole over here over this Indonesia area, but then it would move across the Pacific a little bit, but not where it's spreading out and then over the northern hemisphere, North America, and moving across like that. I have not seen that before. And it could be because of the higher sulfur dioxide readings or levels that we have in the atmosphere now, which is definitely higher. We can look at sulfur dioxide here, and we can see higher, much higher readings all the way across. And it's coming up here out of Alaska and different places. This is what it looks like today. And we even have higher sulfur dioxide over the South Antarctica as well. We're having more reds over here on this eastern side of the world. And it's from different things, from fires to pollution to, different things. Earthquakes. So sulfur dioxide will eat away at the ozone layer, in addition to the production of nuclear energy will eat away at the ozone layer, in addition to nuclear radiation, and in addition to the thermosol spraying or chemtrails that will eat away at the ozone. So the planet's in big trouble. Oh, I wanted to show you something else real quick on the earthquakes. Here's the earthquake map for today, 290 worldwide in the last 24 hours. Here's this event area still going off in Southern California near the Argus Mountains, Coso, Junction, Searles Valley, Ridgecrest. They got 74 here today. I'm still tracking this, but what I wanted to show, I'm going to pull up seven days all magnitudes. Look at down here. Yesterday there was an earthquake right at the tip of the western Antarctic Peninsula, right here where this red line comes down. And then there have been a bunch of earthquakes right over here and over here in the South Atlantic. And of course, all around the Ring of Fire. Also of note had been a series of earthquakes in Kobuk, Alaska. This week, there have been 252 earthquakes here this week. The largest one was a 5.2. Where is that? Here it is, right in the middle. This came in on October the 18th at 6:09 in the morning Pacific time, 17 kilometers deep. Now there's a lot of mining up there. I don't know if this is from mining. There's also, permafrost is melting too. So there's probably a lot of shifting of the plates going on. We've also had huge plates, or not huge, but much larger earthquakes, like a 5.3, 5.3, 5.7, 5.2, and when they're across the plate like that, it'll send the shock waves all the way across to make more earthquakes across. So we've had a lot of earthquakes up here along this Aleutian Island chain. Also here, there are some volcanoes over here that I think could be coming back to life. Also of note, over here on the Juan de Fuca plate, it's a 4.7, and then along the Cascadia subduction zone, here's some over here. They're getting on up there, 3.2, and so forth. Now down here, there have been a bunch down here at the Pinnacles, 49 right here. That's really ramped up, and some larger ones. And the week before last, there were a whole bunch here south of San Francisco. And they're getting bigger. Morgan Hill, and so on. And so here it is in the event area. In the event area in the last week, let's get that in view. There have been 626, so we can see that has not stopped. And then in Southern California, here's the LA area, had some larger ones down here. 2.6, there was a 3 point something too down here, 3.5. Compton. So that's kind of, and then they're peppered around. Here's Yellowstone, here's Oklahoma, here's New Madrid. We've had some more up here in Pennsylvania and Lake Erie, and so on. So in the last week, worldwide, there have been 2,458 earthquakes. Just on USGS, and they don't record all of them. Look, here's one in South Africa, 3.6. Here's one in Algeria, a 4.3. These are areas we don't see. Here's one at Strongoli, Italy, 4.5. 4.4 at Georgia, the state, and so on. There's some over here in Iran, 4.2, 4.2, and so, you know, as things heat up and the weight of the ice moves around and the weight on those plates lifts, the plates will move up and down, and that will cause earthquakes. So we're going to start seeing more and more of this stuff and more cataclysmic stuff happening. Now let's take a little tour at Climate Reanalyzer and we'll wrap this up for today. Here's 2-meter temperatures. Here's the temperatures around the globe today. Here it is in the Arctic. The green is above 0. Aqua is right around 0. The bluish is below 0 and purple is below 0. Then you get into the reds. So here it is. So we're seeing a lot of heat down here in South America, all across Africa, Australia already. It's just coming into their springtime. Here's the 2-meter temperature anomaly. This is warmer than it normally would be this time of year. And look in the Arctic. It's into this dark red, which is about 15 up to 20 degrees Celsius warmer than normal. The brown is 10 degrees warmer than normal. Canada, here across Siberia, here across Europe. Here it is. Here we've got the world view. Here it is in the Antarctic. Red down there. So the northern hemisphere is 1.2 degrees Celsius warmer than normal. The Arctic is 2.2 degrees warmer than normal. The Antarctic is 2.1 degrees warmer than normal. The whole world is 0.7 degrees warmer than normal. Here's the precipitation. The blue is snow. The green is rain. Here's that storm over in the northeast or the east coast of the United States. Here's the jet stream. Look at this. That looks wicked coming down. And it's divided, another schizophrenic jet stream. And the southern hemisphere has another divided jet stream too. Here's your sea ice and snow cover. which we saw. And let's look at the sea surface temperature anomaly. This is from yesterday. They're only a day behind. That's okay. That's better than a week behind. So we can see around where the sea ice is trying to reform or refreeze. It's warmer than normal. It's in the browns and in the red here in the Beaufort Sea. And the Bering Strait coming up is brown. And we've got brown around some of these edges as well. And the sea surface, the temperature of the water is so warm, and you got it's salt water coming up and mixing with fresh water, and the salt water freezes at a lower temperature. So it's a whole thing that we talk about all the time. Here's Iceland. Got brown all around that and around Greenland, and red down here in the Hudson Bay. Here it is around the world. The Pacific is pretty much brown. The Atlantic is a lot of brown. Look, around India, this is where we saw the methane coming up out of the ocean. We saw that on cams. And here, where you see the browns, you've got high releases of methane. Browns and reds. So I'm going to go ahead and wrap it up for here. Again, my name is Margo. If you like my work, I would appreciate you subscribing to my channel, giving it a thumbs up, share my videos. I hope to get back to more reporting and more regular reporting. I will once I get this big storage unit cleaned out. But that kind of takes priority because I don't want to keep spending a lot of money. I've got 3 storage units going right now. 2 storage units with my friend's stuff that I'm trying to clear out. So I'm trying to get back down to 1 small storage unit. So that's my goal before the winter really sets in here. And so that's kind of what my focus is. And but if you like my work, in addition to subscribing to my channel, you can also subscribe to my Subscribe Star page. That's linked below, and I do anytime new methane data comes out on cams, I make a little silent movie and put that up. It's about 4 minutes, a 4-minute movie, and you can see all the latest on the methane. And I put other posts up as well. I do public posts, private posts. You're able to message me over there. It's only $5 a month, and you get an email in your inbox anytime I put a new post up. I do spiritual messages as well, and I've also created a PayPal me link. And so if you don't want to go through Subscribe Star, but you would like to help support me and the work that I do with my time and effort, and you know, the equipment that's involved and the software that's involved with recording all of this stuff, and you can certainly make a donation or a contribution through my PayPal link. I'll leave that in the description box below too. And all of those contributions would be appreciated as well, because you never know what's going to happen. So until next time, my name is Margo. I do believe we are in the end times. I do believe time is short. No one knows the day or the hour. I do believe in being prepared, but mainly we need to be spiritually prepared for what's coming down. And if you haven't done so already, I recommend you get your spiritual house in order and get right with God and Jesus. So I love all of you guys, and so until next time, I'll be praying for you. God bless you. Go in peace, and goodbye.